So today we're going to focus on graphing the square root function. Yesterday you went through the activity after the quiz that showed the inverse of an x squared is the square root, except the square root does not have a domain of all real numbers. So we're going to build on that today. And the square root function has an endpoint because the domain and range are not all real numbers. So the endpoint, what we're going to do to find it, that is when what's underneath the square root, this is called the radicand. That's when the radicand equals 0. So when does x equal 0? That's at 0. When you plug in 0, the square root of 0 is also 0. So when I go to graph that, that's here. Let's pick, for now, let's pick 2 more points that are nice to graph. We can square root 4 nicely, and we can square root 9 nicely. So the square root of 4 is 2, the square root of 9 is 3. So we'll go over 4 up 2, over 9 and up 3. And our graph is slowly increasing. So for domain and range, domain is your x values. There's nothing here until we get to 0. So our domain is x is greater than or equal to 0. The range, there's no y values until we get to this point, which is also 0. So it's y is greater than or equal to 0. Now for increasing and decreasing, we always read the graph from left to right. So as we go from left to right and we walk along the graph, we are going up. So that is increasing, meaning there's no decreasing. For any increasing and decreasing answers, you're going to give an x value or x values. That's because what we're giving the answer is here are the x values for when the y's are increasing, or here are the x values for when the y's are decreasing. So we are increasing on this graph for every x greater than or equal to 0. This is going to be our parent graph and our parent information for the entire day today. This is the beginning. Everything is going to be transformed off of this image. Okay, so if you find this page in your packet, we're going to start with the square root of x minus 3. Let's start with the endpoint. What x value makes the radicand 0? That's going to be 0. When you plug that in, what's the y value? So that's going to be the square root of 0 minus 3, which is 0 minus 3, so negative 3. This point. Now pick another nice x value that you can square root. Let's pick 4. When you plug that in, we get the square root of 4 minus 3. That's 2 minus 3, which is negative 1. Over 4, down 1. Because there's no reflections, I know that this graph is going to slowly increase this way. Domain is our x values. There's no x's until we get to the x value of 0. Range is our y values. There's no y values until we get to negative 3. And if we walk along our graph, we are always increasing. So that's x is greater than or equal to 0. And there's no decreasing. Okay, for number 2, now we're going to take our radicand, and because it's a square root and there's more than just the x under there, we're going to say x plus 5 has to be greater than or equal to 0. And let's solve it for x. That's x has to be greater than or equal to negative 5. So what that means is our endpoint starts at negative 5. When you plug that in, we get the square root of negative 5 plus 5. It's the square root of 0, which is 0. Now, if we think about our transformations, this x plus 5 means move to the left 5. We start at 0 and we went to the left 5. Now, I can't just make x 4 now, because if I made x 4, 4 plus 5 is 9. So instead, I want to know if I make the radicand equal to a nice squared number. So when will x plus 5 equal 4? That's when x is -1. So if we plug in -1, we're going to get the square root of 4, which is 2. And now our graph is increasing because there's been no reflections. Our domain is x is greater than or equal to -5. The range is y is greater than or equal to 0. If we walk along our graph, we're always increasing, but we start increasing here at this x value of -5. So x is greater than or equal to -5, and there's no decreasing value. Okay, for number 3, our radicand is x minus 1. Solving that greater than or equal to 0, we get x is greater than or equal to 1. When we plug in 1, I get the square root of 0 plus 2, that's 2. So I go to the right one and up 2. Does that match our transformations? -1 is to the right 1, and this plus 2 up 2, that matches. Now, when will x minus 1 equal, let's do 4 again. That's when x is 5. So when you plug in 5, we get the square root of 4 plus 2, and that's 4. So we got the 0.54. Our domain is x is greater than or equal to 1. The range is y is greater than or equal to 2. We are increasing for every x greater than or equal to 1, and we are never decreasing. Okay, so now for these last 3, I think we get some very exciting reflections. So let's look at number 4. Negative square root of x plus 7. My endpoint is going to be 0, 7. Pick another nice number to substitute in for x. Let's pick 4. That's going to be negative square root of 4 plus 7. That's -2 plus 7. That is 5. So we'll go to 4, 5, right there. And now I know that this negative in the front as a coefficient means reflect over the x-axis. If I think about our parent graph, it's like this, reflecting over the x-axis makes it decreasing and going down. So using my key point, my 2 points that I just graphed, it's going to graph. Oops, I missed. Try to actually intersect your points. It's going to graph this way. So that's still a domain as x is greater than or equal to 0. But now for our range, since it's going down, we have every y value less than or equal to 7. And if I'm walking on my graph, now we're decreasing. So there's no increasing interval, and we're decreasing for every x is greater than 0. Okay, number 5. We're going to set our radicand greater than or equal to 0. Now you have to be careful because when I divide by a negative, you have to flip your inequality. So that's x is less than or equal to 4. So 4 is the x-coordinate in my endpoint. Now to get my y-coordinate, when you plug in 4, we get -1. And then when will that radicand equal another nice squared number? So let's see, when does -x plus 4 equal 4? That's when -x is 0. So when x is 0, we are going to get 2 times the square root of 4 minus 1. That's 4 minus 1, which is 3. So over 0 and up 3. Now, looking at my transformations, this x inside the radical is a reflection over the y-axis. So if I think about our parent function, reflecting over the y-axis is going to go that way. If I want to be true for all the transformations, what we really have to do is factor out the negative from the entire radicand. So if I was thinking of these transformations, here's my vertical stretch of 2, reflect over the y-axis, left 4, which it's right 4, which makes sense to here. Negative means the opposite, so right 4, and then down 1, which is also, it's been moved down 1. So our graph, when I connect my points, it's going to go up and to the left. So our domain is every x less than or equal to 4. Y is greater than or equal to -1. And now, for increasing and decreasing, we always read it left to right. As I walk on the graph, I'm always decreasing. And we're decreasing for every x less than or equal to 4. Okay, the last one on this page. Do number 6. We're going to set our radicand greater than or equal to 0. So -2 is the x value of my endpoint. When I plug that in, we get -1. What else? Let's see, when x plus 2 equals 4, that's when x is 2. So another nice point, let's see, if we plug in 2, we get -1/2, the square root of 4 minus 1, -1/2 times 2. So that's -1 minus 1, which is -2. And if I think about my transformations, the negative coefficient reflects it over the x-axis, so it's going to decrease. It's been vertically shrunk by 1/2, so it's going to decrease slower. Left 2, that makes sense, and down 1. There we go. So our graph this way. Our range is y is less than or equal to -1. As we walk on the graph from left to right, we're going down. So our decreasing interval is every x greater than or equal to -2. So now for number 7, take a minute and think, what transformations result in a right endpoint? So for example, this is a left endpoint. And back in number 5, this was a right endpoint. So what transformation results in a right endpoint? A reflection over the y-axis results in a right endpoint because, remember, we're going to write in complete sentences, rephrase the question to start your answer so that you make sure you're answering the question. And so now because the graph domain changes to values to the left. So how is the graph of a radical function related to its inverse? Take a minute, discuss that in your groups, then I'll give you my ideas. So the graph of a radical function is related to its inverse. Well, let's graph it. Here's a radical. Its inverse is this way. So the original square root of x, the inverse is x squared. However, our original graph started with a domain of x is greater than or equal to 0. Therefore, the inverse must also have a restricted domain of x is greater than or equal to 0, because the original only had those values to exist in the first place, so that means its inverse, if you think of the reflection, will only have those values as well. Okay, your homework is in your packet. It's this worksheet. Because of the holiday, it is not due until the 16th. If you are not celebrating the holiday, I highly recommend doing it this weekend. If you are celebrating the holiday, I hope you enjoy, and your homework will be due on the 16th.